In this lesson, we will discuss how to observe what class an IP address is assigned to and better understand subnet default mask concepts. IPv4 addresses can hold over 4 billion separate IP addresses. IPv4 addresses are divided into 5 classes. Each class has a range of IP addresses that can be assigned. Class A network can have an IP address range of 1000 to 126.255.255.255. Class A networks have a total of 127 networks, which allows for 16,777,214 total hosts. A Class B network has a range of 128.000 to 191.255.255.255, supporting 16,384 networks, each with a total of 65,534 separate hosts. A Class C network has a range of 192.000 to 223.255.255.255, with 2,097,152 networks and 254 hosts in each of the 2 million networks. A Class D network is used for multicasting, which we'll discuss later when we talk about routing protocols, and a Class E network used for research and future use. Beside the IP address, you need a default mask to allow routing to take place. Each class of addresses are associated with a default subnet mask, as shown in this table. An address using its default mask defines a single IP broadcast domain. All hosts using the same network number and mask can receive each other's broadcast and communicate using IP. A subnet mask must be contiguous strings of ones followed by a contiguous string of zeros to represent the entire 32 bits. When IPv4 was first introduced, nobody really imagined the extent of growth and demand for the IP address space. As time went on, it became evident something needed to be done to extend the life of IPv4. Two things they introduced were RFC 1918 and CIDR notation to allow subnetting of the network mask. RFC 1918 set aside certain IP address groups to extend the use of IPv4. Computers that use these IP addresses can communicate via a LAN network, but cannot be transmitted through the public internet. So if a private network needs to be connected to the internet, it must use a network address translator, or NAT gateway, or a proxy server. The Internet Assigned Numbers Authority, IANA, has reserved the following 3 blocks of IP address space for private internets. Class A are any addresses proceeding with 10 and any number in the subsequent octets. Class B are any addresses proceeding with 172, 16, and any numbers in the following octets through 172, 31, and any numbers in the following octets. Class C are any addresses proceeding with 192, 168, and any numbers in the preceding octets. In addition to the RFC 1918 address space, a few others are considered reserved. Any address proceeding with 127 and any numbers in the preceding octets is reserved for the loopback address or local hosts. We also cannot use addresses with the preceding 0 and any number in the following octets. Automatic Private IP Address, APIPA, is a Class B address space of 169, 254, and any numbers in the preceding octets. It is used by Microsoft as a DHCP failover mechanism when clients cannot obtain an address from a DHCP server. You should not attempt to use the reserved IP address ranges because they will be unable to communicate properly with the internet. Likewise, computers outside the local network cannot directly connect to a device with a private IP address space. Instead, access to such devices must be interpreted via a router or similar device that supports network address translation, NAT. NAT hides the private IP numbers by selectively transferring messages to these devices, affording a layer of security to the local network. In conclusion, we explained the 3 classes of networks, Class A, B, and C, and the available ranges of IP addresses in each class. We also discussed RFC 1918, or Private IP Address Space.